Hi all, today we are going to have a video on solving linear equations and being sure we can go from all forms. The three forms are standard form, slope-intercept form, and point-slope form.
So let's start off by looking at the various forms of equations. First of all, we have slope, intercept equations. The important part of this equation is the m that stands for the slope and the b, the y-intercept. And remember that we calculate slope by saying the change in y over the change in x, or rise over run. The second form of equations is point-slope form. The most important thing about this equation is that it has a xy coordinate given and the slope. The y coordinate is shown in the equation with y1. The x coordinate is shown in the equation with x1, and the slope continues to be m. This form of the equation is important because you can take any point given by your x1, y1 and plot your line. The next form of equation is the standard form, shown by ax plus by equals c. In this equation, the a must always be positive and a whole number. So let's look at how you would use each form of the equation. For the slope-intercept form, shown by this example, y equals negative 3x plus 4, the first thing you should do is identify the y-intercept. Here it is plus 4. And then let's go to our graph and mark the y-intercept. So that point would be 0, 4. And we can show that on our graph by going to 0 and up to 1, 2, 3, 4, and making a point. Now let's identify the slope. It's the number, the coefficient, before the x variable. Here it is negative 3. To graph this, we go to the y-intercept and we graph a line from this slope of negative 3. Now we know when it's a whole number that the negative 3 is really a number over 1. So if we go to the y-intercept, we go down 3, that's the rise, and then we'll go over 1, the run. So we go down 3, 1, 2, 3, and over 1 and make a point. Now if we want to make another point, continue the line, we can continue to go down another 1, 2, 3, and over 1 and make another point. Now we can join these points and we have the beginning of our line. Of course, we know that a line doesn't stop at the points. That would indicate a line segment. So our line continues past these points and should go off your chart. Now if I were using a ruler, my line would be a lot straighter, and you should do that on your graphs. The second form of equation is point-slope form. Here we have the equation y minus 3 equals 2 times x minus 4. So let's identify what we know. First of all, we know a point is 4, 3. So let's graph that point from the 4, 3. And let's go to 1, 2, 3, 4, and up 1, 2, 3, and make a point. Now we've also got a slope of 2, so we could go rise of 2 over 1. Now, on the end of grade test, and usually to make this equation more useful, we'll go ahead and solve it out. So we can rewrite the equation y minus 3 equals 2x minus 4. Now, how would we solve this equation and get it to the slope-intercept form? Well, all we have to do is treat it like a literal equation and solve for y. So let's solve. What would we do first? We should eliminate the parentheses. So let's go y minus 3 equals, distribute this 2 to both of these, and we have 2x minus 8. The next thing that we would do is add 3 on both sides. And then we get y equals 2x minus 5. Now we can graph again from this because we know the slope is 2 and the y-intercept is negative 5. So let's go to our y-intercept, which is 0, negative 5, and make our first point. All right, now we can do our slope from a rise of 2 over what? 1. So it is up 2 over 1, make a point. Up 2 over 1, make a point. Up 2 over 1, make a point. And what do we have? A straight line. Again, we know the line doesn't end with the points. A line continues forever. So we should extend those off our graph. All right, so let's look at one other form, the standard form. And again, the way we usually use this form is by solving for y as a literal equation. So if we did that, the first thing we would do would be minus 2x to get this to the other side. So we would have negative 3y equals negative 2x plus 6. Well, as we stated earlier, you cannot have a negative or a negative number in front of your y or a coefficient, so we divide everything by negative 3. And we end up with y equals 2/3, because the two negatives here cancel out, 2/3 x minus 2. So we can go to our y-intercept and say negative 2, make a point, and we can do a rise of 2 over a run of 3 and make a point. Now, this form of the equation is also very useful in finding the x and y intercepts. And the way we do that is by substituting in numbers. To find the y-intercept, we write 0. And to do the x-intercept, we're going to do it just opposite and substitute in y of 0. So when we substitute in x of 0, we get negative 3y equals 6. So y equals negative 2. So we see our y-intercept is 0, negative 2. Exactly what we'd found earlier when we solved it as a literal equation. But what this form will also give us now is the x-intercept by substituting 0 in for y. So let's look at that and say if we substitute 0 in for y, we get 2x minus 3 times 0 equals 6. So that would be 2x equals 6, or x equals 3. So our point would be 3, 0. 1, 2, 3. And look what we found. Our points are identical. exact same thing. So we can connect our line points. That would be a segment. So we continue them out to make it a line. And we have the line drawn from the standard form.